So we've concluded our chat about polynomials, and the other thing we need to review before we begin Unit 3, quadratics, is we need to review square roots. So the next few days will be devoted towards square root stuff. Nobody ever said gay. Nobody ever said gay. I know. All right, so
We still care about these today, don't worry.
that's okay.
Is that like
If you could teach us like something that's not math,
oh yeah.
we would probably enjoy these.
No, sin my boy.
I know, like that one time we watched SpongeBob, we enjoyed these. Ew, what's the one thing you should
So what is a rational number?
A number that can be written as a fraction.
My goodness, how did you know? So, for example, ready?
Hang on.
3. 3 can be written as a fraction. Because you can think of that as 3 over 1. 3 can be written as fraction.
Is this example 1?
Henry, I'm trying to teach, buddy.
Is this example 1?
No, these are just examples of what rational numbers are. So, 0 can be written as a fraction. So 0 is a rational number. Some decimals, not all decimals, but some decimals can be written as fractions. So for instance, 1.5, that can be written as 3 over 2. Now I'm not going to show you how that is, but it can be. Some decimals that repeat, like 0.1 with a bar over, like 0.1, that can be written as a fraction. That would be 1/9. But there are some numbers that you actually can't write as a fraction, okay? Those numbers are what we call irrational numbers.
Wait.
I'm going to leave the examples, but I'm going to change the top.
Wait, really? Can you do a fraction?
Yeah.
I thought that was.
So part B. What is an irrational number? Yeah. Believe it or not, I know it's going to blow your mind, but it's a number that cannot be written as a fraction.
Oh my god.
I know. Who knew? Who knew? A number that cannot be written as a fraction. That's 0.1 with a bar over it. Yeah. So what is an irrational number? A number that cannot be written as a fraction. So just an interesting and fun little history lesson while some of you guys are finishing your notes. I don't have the details on this enough, but I've heard about it enough to where I can kind of give you the basic gist of it. The ancient Greeks were really into math. I can tell. They actually made like a cultural thing out of it, like almost even like their religion. They actually killed people over math disagreements.
That's scary.
Right?
I feel like you're lying.
No, I'm telling you the truth. Like one of Socrates, I think it was Socrates. No, Pythagoras. One of Pythagoras' students who came up with this idea, they were like, and they killed the guy. They literally drowned him because he had this math idea. So this was actually a big drama issue in the past. They believed every number could be written as a fraction. Now you guys know Pythagoras, right? Pythagorean Theorem. Now you don't need to write this. This is just for interesting math facts. But here's Pythagorean Theorem. Pythagorean Theorem says that if you have two sides of a right triangle, you could square each one. What is 3 squared? What is 4 squared? You can add those together. What's 16 and 9? 25. Take the square root of it. and it tells you the hypotenuse. Okay, that's Pythagorean's theorem. But the problem is that those are all rational numbers. 3 over 1, 4 over 1, 5 over 1. But the problem is that if you had a triangle like this, 2 and 3, they could not find the answers. They knew there had to be a hypotenuse, but since they knew that, since they believed that all answers had to be rational, they could not get a rational answer that would do that. And I think that might have been one of the issues that caused somebody to get killed. Anyway, it turns out the answer to this would be 4 plus 9. If the answer would actually be the square root of 13. There's an answer to that. We don't know what that is, but there's an answer to that. So, you know, if you want to get out a calculator, if you push the square root of 13, you're going to get 3 point something. And matter of fact, I'll just show you what you'd get. There's an answer to it, but it's just an irrational number. 13 square root.
Wow.
So it's 3 point something, right? So, but there's no pattern. There's no pattern to these numbers at all, and they never stop. They just keep going. That's what we call an irrational number. Thank you. It exists. The number exists. It's just that it's irrational. So that was a big aha moment for them. It caused a lot of controversy. But pi is another one. You guys know the number pi? 3.14? You can't write that as a fraction. That's an irrational number.
Okay, just don't listen to my joke, Mr. Brady.
I didn't hear you.
You said you know pi, you said I like pi.
Oh, I'm sorry.
Wow.
Sorry.
Hey, my joke.
So it's
I know, I didn't.
so numbers that don't have nice square roots, that's an example of an irrational number. Another example, as I said, was pi. And there's one that we'll learn about later on this year.
You want us to write this down?
Yeah. Another number we're going to learn about this year is called Euler's number. Euler, believe it or not, you'd think that's spelled with an O, Euler, right? But it actually starts with an E. The guy's name was Euler who found this number. It's like pi. It's just some weird irrational number. It's 2.71 something. It's very helpful when you talk about these things called logarithms. Okay, but these are examples of irrational numbers. So today we're talking about, and for the next couple days, we're talking about square roots. And the big deal with square roots is you want to separate the rational part from the irrational part. Okay? Huh? Yeah, it's an E. All right, so let's begin. I know you guys already know how to do square roots, but I'm just going to review with you. So here we go. Okay, so let's start off with something that we all know, okay? I'm pretty sure you're all going to get this. What's the answer? The answer is 6. I'm going to write it over here, though, because I want to show you why it's 6, okay? Because here's how square roots work. Square roots are something that look for two numbers that multiply by themselves. So, for instance, I could break 36 apart into 6 times 6, can't I? Now, a square root is a machine, and it's a machine that scans for any pairs, and as soon as it finds a pair, it spits one out and drops the pair.
It's like a dating app. Oh my God.
All right.
Kind of.
What?
All right.
What the?
Okay. So I always like to teach, so I'm going to say this later in the year, so I'm just going to tell you now, because this is how I always talk about square roots. I know I'm going to do it later in the year, so if I don't do it now, you guys are going to be wondering what the heck I'm talking about. I always like to talk about square roots with a story about turtles. Okay?
No.
So,
Why?
turtles, do you guys realize they don't raise their babies? They just drop those eggs in the sand, they're like, peace. You know that? Okay. So I'm going to tell you my turtle story, but let's jump into another example before we do. Ready? Number 2.
What was your marriage story?
Oh. He said turtle story, not personal story.
I'm not a turtle.
You just love
I am a little slow like a turtle. Well, guys, let's do some math. but I thought the thyroid medication would take care of that, but no, I'm still Hippie Bailey. I've had a lot of students that think I'm a stoner. Because I'm just, I don't know.
You're just
No,
like, you're
I
just
just have, I'm just a sloth. I don't know what it is.
You know what you should do?
Four times more. Miss Bailey, my favorite animal is
Mr. Bailey, you do look like you're a hippie, like
That's a surfer, but nice try. Okay, you guys ready? So we're gonna break this thing apart. Ready? Not right now. Girls, ready? All right. So, what times what makes 16?
4 times 4.
Okay. Now we could actually stop here because we already have a pair. As soon as you have a pair, you could stop with that group. So I'm going to do that. The first thing you do is you break it apart, right? And here's how it works. When a mommy turtle and a daddy turtle of the same breed, right? You can't crossbreed turtles with tortoises, so it's got to be they got to be the same. So when a mommy turtle and daddy turtle love each other very much, they have a baby turtle and then they leave. Okay? And the baby turtle looks just like them. No evolution. Just comes out just the way the mom and dad look. All right. Let's do another one.
That was great.
That's my turtle story. That's how I always teach square roots. Let's do another one. Henry?
No, my phone was accidentally running. No, my phone was accidentally running.
You're done.
No, it was accident. No, I swear to God. No, I turned on.
You're
I
good.
took oh my God.
But I'm going to ask you to sit right
No,
here.
it's really bad.
No, sit right there.
Look,
Well, you're making me stand just like
Just
that.
really watch.
I'll call your name.
Just go.
I'm not doing it.
Miss Bailey, you're not mean to
They said right stand.
All right. So you guys ready?
You don't do that to me when I don't shut up.
That's not
Not
right.
as much. All right.
Oh.
Here we go. Let's break this down. So what times what makes 24? 8 times 3. Do I have a pair yet? We got to keep going. So what makes 8? 2 and 4.
Oh, we need to do that.
Now I'm going to bring the 3 down also. I don't want to forget about that 3, so I'm going to keep bringing it down every time. Now I don't have any pairs yet, so let's keep going. Let's break down the 4, right? What makes 4? 2 times 2. And then I'm going to bring these two things down. Okay, well now I've got some pairs, right? So what you want to do is break it down until you get to numbers that don't simplify anymore. Like you can't do anything with 2, right?
You can do 2.
You could do 2 times 1, but that would never stop, right? 2 times 1, 2 times 2 times. So let's go ahead, and what we're going to do is we're going to put all these numbers up here with times tables between them, because that's the same thing. 24 is the same thing as 2 times 2 times 2 times 3, right? Now, remember, my square root is a machine that looks for pairs. Do you guys see a pair of numbers that are the same?
So you get the pair.
So when a mommy turtle and daddy turtle love each other very much, they have a baby turtle that looks just like them and they leave. Okay? Now, these guys cannot have a baby. This is a lizard and this is a turtle.
Wait.
They
where
cannot
did the
breed.
lizard- where did the lizard come from?
I'm just making stuff up.
That should have been a tortoise.
Now-
If they had a tortoise and the turtle can't cross breed, it should have been a tortoise. Come on,
That was a
it's
4.
tortoise.
That was a 4. Get with it. Okay?
Ooh.
Now, 2 times 3 is what? 6. That's my final answer. Now check this out. This is a rational number.
How I learned it.
This is a irrational number.
How I learned it is.
You could do it if you know how to do it and you know how to do it well, then do it. You don't have to use much strategy.
Well, I mean, it's kind of, it's not that hard to do.
Go
Like,
for it.
there would be prisoners in jail, and then she would leave together, and then, yeah.
Oh, I like
And
that.
then the other one would stay.
Let's do one more together. We're on example what now? 4?
Are you judging me for remembering how to learn? Oh, I was thinking that. Because we learned it together. You never
Hmm.
know. You were in the same class as me. Yeah, I know.
She's probably not proud of that.
That's me.
Mr. B.
Well, maybe you're right.
Oh.
Oh,
I'm just
wow.
kidding. Look, we have
Whoa.
plus
34.
No,
Not
I'm gonna do
really.
72. All right, go right to 72. All right, so I'm gonna have you guys. I want you guys to try. This is what I want you to do. I want you guys to try to break this down all the way.
How do you break it?
Go for it. I'll pause. I'll give you some time. Talk to each other. Yeah.
Yeah.
What did you get, bud? Augustine.
I got 3, 2.
All right, good job. Now, if you want to see why, this is 8 and 9. This is 4 and 2. This is 3 and 3. This is 2 and 2. Bring that 2 down and bring your 3's down, and you've got 3 2's and 2
Can I say
3's.
the way I did it?
Yeah,
Sure, what'd
I
you
did
do?
a little
I did
different.
36 and 2.
That would work.
I did
That
a
would
little
work.
different.
That was like,
I'm going to show you guys something with what he said in a minute, but that works. Okay, let's go ahead and continue here. So David's not with us, but I'm going to ask Gabby. Gabby,
wait, what happened to David?
where are my babies?
The 2 pairs of 2's and then the 3's.
So the 2's can have a baby, the 3's can have a baby,
With the 2 by itself.
and this one is a loner.
Me too. Wait,
So we have 3 times 2 is 6, and on the inside, a 2.
Mr. Ben, you should give her extra credit to do these words with us.
yeah, I said it.
What did you say?
Okay,
Wait, Mr.
I will.
Oh, I'm sorry. No. Oh, wait. Doesn't matter what order it is. Like,
No. Now I want to show you guys something interesting, by the way. Two interesting things. Here we go. Let's look at this one again. John said 36 times 2. Right?
2 can't go down anymore.
That works. But watch this.
But that's just extra.
Do you guys see how I've already got a pair?
Yeah.
Now I could break these down more, right?
It's already got your answer.
But why break it down more when you already have a pair?
What was that,
Out of
Hannah? Was
6,
that
that'd be
extra? Really?
6.
So do you want to find your like
Oh.
So here's what I'm going to say. If this is like shaky ground for you, do what I showed you at first. But if you want to start getting creative, look for perfect squares that go into your
I'm
number.
smart, huh?
All right, now here's another thing. Here's another thing.
Oh, okay, done.
If I gave you guys this, the square root of 10, we would break it up, right?
5 and 2.
Does anything come out? So what would you write as your answer? You would just leave it. It's just an irrational number. So be aware that not everything simplifies.
So you start answering together.
Yeah, absolutely.
Is that a example
Will you
one?
put like trick questions on a homework like that?
I don't consider that a trick question because I just revealed the secret to you. So it's no longer a trick.
Okay, Mr. Bailey, can you use your stapler now?
I could. All right, so here we go. This is student practice. Let me throw a couple at you here. Square root of 18. Give me a square root of 28. Give me a square root of 96.
Okay.
And that'll be good enough. That's the right answer. We're good. Let's go ahead and move on to example 2.
Times 8.
That was a lot of 2s.
This is most starting to make you work. Wait, what the heck?
Yeah, but we're going to do a little more than that. So, the rule for math here
Hang on.
is that if you're multiplying 2 square roots, you could put them under one common square root symbol. So you can write it like this. Okay? So if you have 2 square roots that we multiply together, then you can put them under one square root. So in this case, I've got the square root of 6 times the square root of 2, which means I can do this. Now, I could multiply those together and get 12, right? But I'm not going to. Why? Because we need to break them apart anyway to take out the pairs, right? So don't actually multiply them, but just put them under the same root. Now, let's break apart the 6. What does that make? 3 and 2. All right, so that means this comes out to be 3 times 2 times 2, and I can take out a 2. And so your final answer there would be this. Okay? I'm going to throw one at you guys to try. Student practice. Ready? Square root of 8 times the square root of 2. Go. Yep, that's a student practice. So let's, I don't know if I was recording that, so I'm going to say it again. The special thing about this one is the outside numbers get multiplied together and the inside numbers get multiplied together. And then you just simplify the inside the way we have them. All right, let's go ahead and take a look at another student practice here. 5 square root of 2 times 2 square root of 6. That's for you guys. Go ahead. That's yours. Show me what you got. Great. All right, good. So that's the primary step. That's the first thing you want to do: outsides together and insides together. So let's go ahead and ask. Not here, Danielle. What's our next step?
You're gonna break down 6.
Excuse me. Okay. So do I have a pair? Now that I've done that,
Yeah.
I've got 2 2s, right? So that means mommy turtle, daddy turtle have a baby. They leave. And on the inside, I'm left with
That
what?
baby then reproduces.
And then 2 times 2 is 4 times 5 is 20.
The baby then has a child or another baby.
It's the circle of life. Or the circle of squares. All right.
You look way too excited right now.
Don't judge my joy. That's why I'm a math teacher. All right. Example 3. Actually,
Scratch that. We're done for today.
we're almost there. What does it mean to rationalize? Write that down. What does it mean to rationalize?
Ratio.
Yeah, it's relevant. All right.
It says ratio 8.
So, what this means is that
She is like a cheeseburger.
She has a cheeseburger.
I believe so. I said she
So guys, to rationalize means that if you ever have a fraction that has a square root in it, in the bottom, rationalize means get it out of the bottom. Now the reason we do that is because, remember I talked about rational and irrational and we like to separate those. That's how you have to do it when you have a fraction. You get it out of the bottom and that will allow you to separate them. So yeah. I'll read it. What does it mean to rationalize? It means to get square roots out of the denominator. Okay? Now, before I show you guys how to rationalize, I want to show you something else. An interesting note, or I guess we could say an interesting fact. Here we go. Ready? Square root of 2 times the square root of 2. What is that? That's going to be the square root of 2 times 2, right? And they have a baby, and the answer is 2. Now here's your rule. You ready? Anytime you take the square root of something and you multiply it by the square root of the same thing, you just get that number. So like for instance, square root of 8 times square root of 8 would be 8. Square root of 2 times square root of 2 would be 2. No, just 2. All right, so that's our interesting fact, and we're going to use that interesting fact to rationalize. Okay? You guys ready?
I have no one.
Are we good? So let's do example 3. Ready? Rationalize each expression. Here we go. Number 1. 5 over the square root of 2. What don't we like here? We don't like that there's a square root in the bottom. So we need to fix that. Because we like to separate the irrational from the rational. And so we don't like this. So, you guys ready?
No.
Here's what we do.
I'm not ready.
I don't want this to be the square root of 2. I want it to be just 2. What can I multiply the square root of 2 by to make it just become 2? You multiply it by itself, which is totally legal if you also do it to the top. So that's how fractions work. You can, if you multiply something to the bottom, that's okay, so long as you also do it to the top. That keeps it balanced. Okay? So here we go. Now on the top, this is oil and water. They don't mix. We have a rational and irrational. They don't go together, so just keep them separate, right? On the bottom, though, what's this make? Square root of 2 times square root of 2? Shortcut? It's just 2. There's your answer. You could also write it like this if you want to. That way we're separating the rational, the fraction, from the irrational. Okay? I'll do another example with you.
Wait, I'm kind of confused.
Okay.
So people.
All right, so what am I going to multiply to the top and bottom this time? The square root of 3. So what will I have on the top? 6, square root of 3. And how about on the bottom? 3. Now this one I can go a little bit further. I can reduce those because they're both non-roots. They can reduce together. What's 6 over 3 make? You could say, yeah, no, 2 over 1, right? So if you reduce that, you get that. Do we ever really need to write ones in the bottom, though? You don't. So here's actually the best way to write that answer. Now this is all just old stuff. I'm not too worried about the reducing and simplifying. I'm worried about, do you understand this, getting to this step. That's good for now. I would like you to be able to do that, but that's what we're focused on right now. Let's do another one. Yeah. How about matter of fact, we'll do one for you guys. Do this one. See what you get. 7 over the square root of 5. Let me catch up with you here. So what do I multiply by?
Okay, on the bottom, you're multiplying by square root 2. On the top, that's square root 3.
No.
Also square root 2.
You have to do the same. So here's the thing. Before I go any further, what number is not okay where it is? The bottom. You can have square roots in the top. We don't like them in the bottom, so I need to fix the bottom, right? So we do want to do that, but whatever we do at the bottom, we do that.
And then that would give you, I believe it would give you 6.
You're right. Why can we multiply them this time?
Because they're both square roots.
They're
That
both
gives you
square roots.
square root 62.
Let me ask you a question. Can I reduce these?
No.
No, because the top is a square root and the
And
bottom
that's
is
your
not.
final answer.
That is our final
I'm
answer.
smart.
Okay, so it's all about keeping the rational separate from the irrational there. So yes, we can multiply these, but no, we can't reduce those because if they're both square roots, you're good. If they're not both the same, you can't. So let me throw one more at you, and I think we're going to call it a day. How about the square root of I don't know. Let's keep it prime. 7 over the square root of 3. See if you guys can do that. All right, guys.